All right, and hello everybody, and welcome. This is the screensaver of my computer in this cave in Bulgaria. I don't know how to say these words, and we'll take a look at. This is from Wikipedia. Internal combustion engine. And of course, we do want to say welcome, and we're glad you're here. I'm glad you're here. I have a YouTube channel. Its name is Patrick Gray, and I invite you to subscribe. I think you'll enjoy it. Today, we're going to talk about a power source, an energy source for a robot. We're discussing the issue of making a energy source that can last long enough that the robot can work for 8 or 9 hours, and also an energy source that doesn't make any noise. And I think this can be done with fossil fuel, and that's what I want to address. The normal fossil fuel of engines is an internal combustion reciprocating piston combustion engine. It runs on fossil fuel. So internal combustion reciprocating piston fossil fuel engine. And they have on Wikipedia, there it is, going up and down. Fuel is put in there. A spark happens, it generates pressure, it pushes the piston down, creates exhaust. When the piston is connected to a crankshaft, so when the piston goes down, it turns the crankshaft and generates torque. Several interesting things. With this engine, if you wanted it to make more power, all you really have to do is run it faster. If you run the engine faster, you don't have to make any new parts. In the old days, they didn't have high-speed, reliable digital sensors or digital controls or digital processing or central processing units. So these engines were optimized to have negative feedback loops in their mechanical parts so that whatever was happening to make the engine not work, the negative feedback loop would prevent that from happening. And an important issue that you have to understand: as you run the engine faster, it has to get the exhaust gases out faster. And the definition of sound volume is the difference in pressure between the gas that you're putting into the air and the normal atmospheric pressure. So as you run the engine faster, the only way to get these gases out faster is to put them under more pressure, so that when you run an internal combustion reciprocating piston fossil fuel engine, I'm just going to call it an IC engine. If you run an IC engine faster, it makes more noise. And the question is there some way for this to be changed? And of course, I advise, do not create anything if you cannot manage it in a manner that is legally allowed and reasonable and safe. SketchUp. This is a SketchUp drawing, and this is an injection nozzle blown up to a fairly significant size. This nozzle is made of ceramic, and inside this nozzle is a nickel-based nichrome wire where electric power can be put on this wire, and it will heat up this nozzle. And here's the interesting thing about fuel. If you take fossil fuel and get it at a significant pressure in an atmosphere where there's no oxygen, like in a metal tube, you get it at significant pressure in a metal tube with no oxygen and heat it up, you can heat it way beyond its combustion or ignition temperature. You can take this fuel and spray it through this nozzle. It will come out of this nozzle in a nebulized fashion of little tiny droplets of fuel. And if you put electric power across this wiring, this nozzle itself can be hot enough that it raises the temperature of the fuel beyond the ignition temperature of the fuel. So you have these little tiny droplets of fuel spraying into air, and they are above their ignition temperature, so they will immediately light on fire and begin combusting as soon as they get out of this nozzle. And so here is another engine that I created that works on a completely different concept than the normal reciprocating piston internal combustion engine. The fuel is blown through this nozzle into the cap of this combustion chamber. And when the fuel is blown through this nozzle, this combustion chamber has air in it, and the air is under pressure. It's just plain air, 20% oxygen, 80% nitrogen. This fuel is blown into this combustion chamber at a temperature above its ignition temperature. So if you blow the fuel in there slowly, okay, you get a small flame. And if you blow the fuel in there more quickly, you get a big flame. And the crankshaft, and this is an engine that creates pressure, pressurized fluid. The crankshaft of this engine is connected to this fluid pump, so that when you blow this fuel into the combustion chamber and it increases the temperature of the gas in the combustion chamber, the temperature in the gas in the combustion chamber will not go up. Instead, as the temperature begins to rise, it will increase the pressure in this combustion chamber, and that will push this piston down. And when it pushes this piston down, it turns the crankshaft, and that will pump fluid to create fluid under pressure. But you could also have the crankshaft attached to a generator. And you might say, so how is this different from a regular internal combustion reciprocating piston fossil fuel engine? And my reply is, there's no lower limit on how slowly this engine can turn, because the way in which this combustion chamber piston goes down is related to how fast you're injecting the fuel. If you inject it slowly, you get a little tiny flame and it goes down slowly, but it doesn't care. It will go all the way down slowly till it gets to the end of its cycle. This means you can increase your power by enlarging the diameter of this cylinder and run the engine at whatever RPM you want to run it at. And the slower you run this, the lower the difference in pressure will be between atmospheric pressure and the exhaust gases when you exhaust out the exhaust gases, which means the engine will make less noise or perhaps no noise. Now, when this combustion chamber piston is at the bottom of its cycle, this combustion chamber is full of hot and pressurized air. There's a lot of energy in that air, and you don't want to waste it. And so what you do is you take the, and I'm going to say, didn't read my own writing. Excuse me. This is not the combustion chamber. This is. Doesn't make any difference. But once the combustion chamber is full of this hot and pressurized gas, you don't want to waste that energy. What you do is you take that hot and pressurized gas over to this chamber, and you let that gas push this piston down. And when it pushes this piston down, the action of pushing this piston down pushes that piston up. And the reason why this one goes up when that one goes down is because they're all connected together in the crankshaft. And this is all made of metal. I have lowered the opacity of it so you can see what's going on. But what you did is you took all the energy in your combustion chamber. During the time this piston was going down, that energy was used to run your pump. But once it got to the bottom of its stroke, you use the energy in it to create the charge of compressed air that is going to be put into the combustion chamber when it's time for the combustion chamber to begin its next cycle. And the final thing I wanted to show you was this is just a valve here. And so as this valve turns around, it changes where the gases are sent to and where they're allowed to go to. And this valve is connected to the crankshaft. So, there's the piston supercharger. So here's the compressed gas, and that gas will be sent over to put in the combustion chamber, and then the combustion chamber will go down, and then that gas will come out of here and go over to the supercharger, and the supercharger will go down, and when the supercharger goes down, it will compress the gas, and then the gas will be sent over to combustion. And all that is controlled by this valve. And all of these parts, I think, can be made of one of the alloy stainless steels, and in a vacuum plasma discharge system, they can be coated with boron nitride, so that boron nitride is very hard, very resistant to heat, can be made very nice tolerances, and these will be able to slide around on each other without necessarily needing to be well oiled, or at least they can be oiled some, but they won't need a lot of it. And I rendered these in various amounts of rotation of the crankshaft, and stitched those rendered images together to make a video of this engine running, and that video is on my website. And here's my website, and there's the menu, piston robot, heart of the robot. You can download this if you want, but there's this engine just turning, just to show you how everything works. And I was thinking to put this engine inside the thorax of the robot. And I'm not quite sure how big this engine needs to be. This was done back when my robot didn't have arms on it. And I made a series of images of the robot walking along, and I measured how much the different pistons changed by and got the fluid flow to try to figure out what RPM or what size that engine needs to be. And I wanted this engine to run at 60 revolutions per minute, so it would be running at the same rate as the human heart was beating. And I had in my mind an image to make a story just to popularize it, where a female went to walk in the wild forests of Nepal or somewhere, and the rebels were after them, and the robot helped and got her out into the forest and escaped from the bad guys. And it was a little bit rainy and cold, and he runs this engine with fossil fuel so he can warm up his chest if he wants to. And she's sort of just up against him and puts her head on his chest and her ear, and she says, "Oh my goodness, do you have a heart beating inside of you? What is going on here?" And it's the engine. He says, no, that's just my power supply. But I thought that was a cool story. And this again was some images from that video that I made. And I actually went to Google Images and got this image. I paid for the rights to. I never could get the story done. It takes a long time. But she has that, to me, look on her face like my adventure trip to the wild jungles is not going the way I wanted it to. Anyway, I thought that was kind of fun. That's the discussion about the heart of the robot. And my final point is, particularly the military, they're going to want this robot to walk along with the troops for 6 or 8 hours. They don't want a robot that runs the battery out in 40 minutes. And one thing about fossil fuel, it has such a density of energy in it. And you can refill and put a gas tank in the robot's thigh. And if he needs more diesel fuel, you just put more in there. That is to me, right now, with battery technology, this is a better system. And it can be controlled with digital sensors, digital controls, and digital central processing, so that everything that makes these engines tend to not work can be counteracted, and it will work, even though it's running at 60 beats per minute.